Hello everyone, can you hear me? Yeah, okay. So my name is Sasha, and I'm going to talk about Elixir, specifically about metaprogramming with Elixir. And I'd like to check first, who knows about Elixir? Who's familiar with it? Some people, okay. And who's using it at their job? Okay, some people, that's nice. And who knows about Erlang? Less people than Elixir. Yeah, that's curious. So, before I start, I'd like to make a point. That is that Elixir is bringing old ideas from to the modern world. And that's because Elixir is made on top of a language called Erlang. And before I start about Elixir, I have to explain and give a brief overview about this language. And basically, Erlang, it's a language that was built in the 80s by Ericsson. The first release was in '86. And it's a language that was developed to solve the problems in the telecom domain, namely the need to have many concurrent connections, to have high availability in their switches, and to be able to update their systems without ever having any kind of downtime. And Erlang has some features, which are the old ideas that I want to talk about first. And the first one is functional programming, which is all the rage these days. You see a lot of blog posts and articles about how functional programming is so relevant and revolutionizing. But it's actually one of the oldest, if not the oldest kind of programming there is. And it gives great expressiveness and easy reasoning to our programs. And with functional programming, there also comes immutability, which is the lack of side effects, and it lets us have predictable behavior in our programs. And Erlang also has something called no stop the world garbage collection. And for those that don't know what that is, well, in some languages, like Java, for example, which was released about 10 years later than Erlang, when there's garbage collection, the system must stop executing until all the garbage is collected. And in the case of Erlang, that can be done without ever stopping the system, so we have better performance than in stop-the-world languages. Besides that, Erlang has something called tail call optimization, which gives increase in efficiency when using tail recursion, and also provides higher order functions, which give a great deal of scalability, since you can give certain tasks to each process, and you can have a great level of context and modularity for each process to act on its own without having any kind of state. Erlang also has pattern matching, which allows you to match on certain use cases, and also has something called share nothing concurrency. And this is something which is probably the main point of Erlang. And what share nothing concurrency does, it allows us to never have any kind of state, and there's no shared memory or data, and the processes just communicate through messages. And that allows us to have a billion of processes all acting on their own, since they're all independent. And besides that, these processes are lightweight processes. They have about 1/3 of the size of Unix processes, and each one of them has their own stack, and the garbage collection is also done intra-process. And so that's why there's the no-stop-the-world garbage collection. Erlang is also famous for its fault tolerance mechanisms, which give a lot of robustness and resiliency to the Erlang systems. And this is a typical use case of Erlang. Of course, it's a joke to simplify it. But these are two of the three creators of Erlang. It's Joe Armstrong and Mike Williams. And they want to check on the Erlang system. So they call each other and say, hello, how's the system? And they say, it's fine, because Erlang doesn't crash. It's autonomous. So it's all fine. And Erlang doesn't crash. Well, in reality, it crashes, but it can recover due to supervision trees. In Erlang, you can give each process a supervisor, and each supervisor can have another supervisor. So you can have a supervision tree that when one process crashes, they will be restarted by its supervisor. Not only that, but these supervision trees can be distributed across many systems and many machines. So if one machine crashes, the other machine can recover it. And that's how you get distribution in Erlang. So there's a lot of scalability and possibilities to adapt to certain situations. And besides that, Erlang also has the hot swapping, which is the possibility to update the system without ever having to stop it. And sometimes people ask me, but what's the deal about Erlang? Why is this unknown language being talked about? It's not really an unknown language. In fact, these are some of the companies that use it. We have WhatsApp. WhatsApp was entirely built on Erlang, and they've managed to have about 2 million clients serving on a single server. And also the Facebook chat end is also made on Erlang, and Call of Duty multiplayer servers, Bet365, and also some financial systems at Goldman Sachs. And in the case of Elixir, there's companies like Pinterest, Discord, Lexmark. In Portugal, we have TalkDesk. There's also the game company 22 Cans and a betting website called Butcher Report. So, I've talked about the old ideas, but what about Elixir? What does Elixir bring to the modern world? Well, when Elixir was built, its creator, it's a guy named José Valim. He wanted to use Erlang, but he wanted to have all the features from modern languages applied on this old and tested platform of Erlang. So he added Ruby syntax, syntax very similar to Ruby, and in fact, one of the pain points of Erlang that you'll see a lot, it's the dislike for the syntax. So Elixir has this Ruby-like syntax, which is much more modern and user-friendly. And also from Ruby, it gets the build tool, which is very similar to Bundler, and also native unit testing. So you can have your own test cases built all in the same application using standard libraries. It also gets Markdown doctrine, which were inspired by Python, and also lazy streaming, which was inspired by Haskell. It also got pipelines, the pipe operator, which was taken from standard ML and F#. And what the pipe operator does is, instead of writing this chain of functions, which is hard to read at first sight, you can just change to this much easier and more organized way of structuring your code. Also from Clojure, Elixir has got polymorphism and protocols. And from Lisp, Elixir has got metaprogramming. But for those which are more knowledgeable in programming languages, you probably know that Lisp isn't a modern programming language. In fact, Lisp is a really old programming language. So why did Elixir have all these modern features from modern languages, but why did it resort to this old feature from a really old language? Well, to answer that, I must first tell you what is metaprogramming. And metaprogramming is a paradigm that dates back to 1958 with the introduction of Lisp. And it's a paradigm where programs consume other programs as their input. So in metaprogramming, you have a certain object language that is going to be manipulated by a meta language, and it will result in a new program. And in languages like Elixir, where the object language is the same as the meta language, it means that we have a reflective language. So in the case of Elixir, we have Elixir manipulating Elixir to generate a new Elixir program. And this is done through macros. And macros are a set of instructions that are expanded automatically at compile time, and then these instructions can be used at runtime. So, but you may ask, what are the benefits of going through all this trouble? Well, metaprogramming can give you an increase in productivity, since you can generate code automatically from external data, or you can remove boilerplate code, since you can inject all the boilerplate into the context that you may need. And also you get a lot of expressiveness, since you can create domain-specific languages, or you can extend Elixir itself which we'll see at the end of this talk. And this gives great expressiveness, since you can operate on different domains without having to change languages. So in some languages, you may have to maybe do some configuration in XML, but in the case of Elixir, you can do everything in Elixir, and that can apply to other contexts and domains like SQL, or you can create a specific domain language for your own project. You also get a great deal of optimization, since you can do compile time manipulations. And you get modularity, since you can structure the application logic into separate contexts that you can then manipulate. But before writing macros, we must understand what are the rules of macros. And you'll see this in Elixir a lot. These are two rules that are mentioned a lot. And the first one is that you must write macros responsibly. And this is because macros are hard to reason about, and they can be really difficult to debug and to correct your errors. So you must be responsible when writing macros. And you can't just use macros for the sake of writing macros, because that can lead to hard life. But however, the second rule of writing macros is write macros responsibly. And this may seem like a contradiction to the first rule, but if you want to get good at macros, you must write a lot of macros to understand how metaprogramming works and how macros work, so that you can take full advantage of Elixir's metaprogramming. So let's get started in metaprogramming in Elixir. This will be a good overview of this paradigm. And Elixir is a great language for metaprogramming, because it has first-class metaprogramming interests and mechanisms. And the language itself is built on with macros. For example, every operator or keyword you may see is actually a macro defined in Elixir. So if you define a module, a function, or the if conditional or a case conditional, everything under the hood is actually a macro. And these macros have access to the language. So when you're writing code and you write a macro, if you want to use anything from the standard library, you can use, and the macro will be able to call those functions. So for example, in this case, we have this module pixel scan, and you have the first print of pixels at compile time, and that print will be shown at compile time, and the print inside the full function will only be shown at runtime when the function is called. So you can see that Elixir can get the I/O module and its functions at compile time and use them like it was runtime. And this is possible because in Elixir, everything is in expression, so there are no statements. And this is actually because the way Elixir is compiled, because Elixir actually uses something called an abstract syntax tree, which is an intermediate representation of a language source code. And in the case of Elixir, this AST, this abstract syntax tree, is actually a three-element tuple. So in Elixir, if you have the expression 1 plus 2, you will get the three-element tuple, and the first element is the function. The second element is a list with metadata, and the third argument, third element, it's the list of arguments of the function. So in this case, what you actually get is a three-element tuple with the plus operator, the list with the metadata, and the list with the arguments for the function. And this happens because in Erlang, you start by writing the source code, which then gets transformed into the Erlang abstract format, which is the Erlang AST, and it does another pass from curl Erlang and to kernel Erlang, which are more human-readable formats of the abstract one, until it reaches the virtual machine bytecode. And in the case of Elixir, what is actually happening is that you write the Elixir source code, and then the macros are expanded, and then they're sent to the abstract format, where they're going to be compiled to the Erlang bytecode. And it's in this macro expansion that the metaprogramming happens. And it's due to this way that this is structured, where you can write Elixir source code that is going to be expanded into Erlang abstract formats, that everything can be evaluated and everything is an expression. Because in the end, everything is going to be Erlang. So you write Elixir to then generate an Erlang abstract format. And this leads us to the concept homoiconicity, which means that programs are represented through a primitive type of the language, and this primitive data type is the three-element tuple. And so you can treat these, treat programs like the regular data, since they're actually being represented as a three-element tuple in Elixir. And to operate on this metaprogramming paradigm, you just need to know pretty much about two operators. One is the quote operator, which returns the internal representation of an expression. So when you quote something, you get the three-element tuple. Like in this case, if you do the quote of 1 times 2, you get this three-element tuple with the times operator and the arguments. And then you must need the unquote operator, which is the inverse of quote. And this actually does is inject the expression value into the macro. So if you have a variable, number equals 5, you quote and then unquote the variable number times 10. And what you get is this three-element tuple with the times operator and the arguments of 5 and 10. And from here, you can operate on this and generate functions for Elixir. So this is a visual representation. If you quote the expression of 5 times 2 minus 1 plus 7, you get that ugly syntax tree on the right. But what this actually represents, it's the visual representation on the left side, which is a much more human-readable format. But even in these cases, where it can get really messy, Elixir has certain libraries that can help you get through it, and it's actually quite easy to deal with nested ASTs. So I know these are a lot of concepts, so to better understand this, I'll show some examples of what you can do with metaprogramming in Elixir. And the first one is the removal of boilerplate code. And this is some code from a framework called the Phoenix framework, which is a framework for building web applications in Elixir. And you have defined the function for controllers, which has certain boilerplate code. So this code is what you want to every single controller to be able to utilize. And what you're going to do is use this special macro down there, which is called the using macro, and it's going to receive a which argument, and that argument is going to apply the function that you are passing as which. So if we pass the controller as the argument, you are going to receive all the boilerplate code that is inside the controller function. Like so, at implementation time, you use the example and pass the controller. And what this is going to do at compile time is get that previous boilerplate code, and it's going to inject into your controller. So at runtime, you have access to all these libraries that you may need without having to write this boilerplate over and over again. Also, an example about dynamic code generation. And this is one of the strong points of metaprogramming, since you can have a great deal of productivity out of this. And this is the router in the Phoenix Web Framework. And you link a certain URL to a controller. And in this case, it's the controller pages with the show function. And under the hood, what Phoenix is doing, it's actually generating a match function for each one of those URLs. So to that show function that we defined, Phoenix is generating this match function, which will then redirect the user to that given controller with the show function. And this is all done transparently. and you don't have to worry about it, but since Phoenix deals with this through metaprogramming. And actually, if you look at Phoenix source code, you'll see that it's actually really small source code for a web framework. And this is all because of metaprogramming, since it used metaprogramming to generate pretty much everything that has a certain kind of pattern. And also about domain-specific languages, or DSLs. You have the Ecto library, which is a really popular library for Elixir, which is a DSL for writing queries and interacting with databases in Elixir. And it has certain drivers that, through metaprogramming, allow you to interact with the most popular databases, like MySQL or PostgreSQL. And you don't have to ever change your code if you change your database, since the metaprogramming is generating dynamically the SQL dialect that you need for that certain SQL engine. And this is done through a series of macros. Like in this example, you have the join macro, the where macro, from macro. And what it's going to do is that you write in the Ecto DSL, like so. So you write in Elixir, you write this query, and then at compile time, this is going to be transformed into this SQL query. And you never need to change languages. You just need to write in Elixir. And you write, and you get this SQL query, like in this case for MySQL. But if you change to PostgreSQL, it will work all the same, since it will generate the equivalent query for Postgres. And it also does database migrations and schemas for your applications. And you also do this in Elixir. And it will generate all the migration and the models and the tables for the SQL database. And finally, I'd like to show you a live coding example of extending Elixir. So let me change here. Actually, no. In this example, I'm going to show you how to build an assert operator, because Elixir standard library doesn't have an assert operator like other languages. And what we're going to do is build this assert operator where you take the left-hand side and you are going to see if it's the same as the right-hand side. We're going to get the result. So since Elixir doesn't have this, we're going to add one. I'll go here to my editor, and I'll start by defining a module called assertion, right? And we want to define which operators we want to support. So I'm going to write operators, and I want to take the equal operator, the different operator, the and the less than operator, and the greater operator. And remember, in Elixir, everything is an expression. So that's why we can pass the operators as this list, since this is going to be, at compile time, just an expression that is going to be transformed into Erlang. And we want the less and equals, and this one. I'm doing this in a list in Elixir, but this could be like an external source. You could be getting data from an API. And then we're going to make this cycle where for every operator in operators, we're going to define a macro called assert. And the argument will be the AST, the three-element tuple that I talked about. So the function will be one of these operators. We don't care about the metadata, so I'm going to pattern match it to an underscore. So it will be discarded since I don't care about it. And the arguments are going to be the left-hand side and the right-hand side, right? And we can, through pattern matching, say this is our expression. So I'm going to quote everything. So everything is going to be transformed into the AST. And I'm going to define a left and I'm going to use unquote. And what I'm doing here is I want to get the value of the left-hand side, because remember, it's inside the AST, but I don't care about the AST, I want about its actual value, right? So I unquote the left-hand side, and I unquote the right-hand side to return its actual value. And I also want to get what was the expression that I tried to evaluate. So what was my code? My code was the unquote of macro toString, and this is actually a special Elixir function that returns the string representation of a given expression. So I'll pass it here the expression, and this will return the string representation, and it will be assigned to the code variable. And I also want to know what the result was, and for that we're going to do something more complicated, and I'm going to do the unquote of the operator. So I'm going to unquote the function to get the actual function value, and then I'm going to pass the left-hand side and the right-hand side. And this may seem strange, but what this actually is doing is, if the operator was the equals operator, then we'd have this 1 equals 1, which is the equivalent to equals 1 with 1, right? Because it's the function. This previous 1 equals 1 is just syntactic sugar for the actual function, which in the case of the AST is also going to be parsed as this, right? So the AST is going to see the equals operator with the 2 arguments. And from here, I want to evaluate the result. So unless the result is true, or for other words, when the result is false, I want to do something. Well, let's return here. And this got messy. Yeah, live coding never goes right, can it go? So I'll return the result here. And inside this conditional, I'm going to do something like output assertion failed, right? I want to see what the code was, why did this fail, and I'm going to pass the code here, and I'm going to pass the left-hand side. The left-hand side here, and the right-hand side. Right? So, is everyone clear on this module? Any questions? Well, I can come back to this later if you want. Now let's see how this works. I'll come here, and I'm going to use my module. And if I do assert, it doesn't work, right? Oh, I'm sorry. If I do assert 1 equals 1, it doesn't work, right? Because Elixir doesn't have the assert operator. But if I import my module, then I can go back, and it works. And it works for every operator that I defined. And now in my code, I can, in my code, now I can use this. Like I can define a new module, and I may use it how I want. Like let's write this does it rock module, where I'll check if the string contains the string rocks, right? And now I can just pass a certain string, and it works. So I defined this assert operator inside Elixir, and I extended the language to now have this new operator. And you could now, for example, build a test framework from this assert operator, or you could define other macros to use other operators and define whatever kind of operators you may need for your project domain. And from here you can also build domain-specific languages, or you can generate an API from an external function, from an external data. And that's it. That's one of the great things about Elixir metaprogramming. So, as closing words, I'd like to remind you that metaprogramming is a really old idea. Sometimes people talk about Elixir's metaprogramming like it was something new. It isn't. It comes from the 50s. Remember Lisp? But Elixir gives it a modern spin through Erlang, right? And metaprogramming allows you to write less code while achieving more work, so you can write less and get more work done. And macros will increase the quality of your software, but also your productivity. But always remember, with great macros comes great responsibility. And in case, if you're interested in Elixir or in metaprogramming with Elixir, there's the Programming Elixir book, which was written by Dave Thomas, and this is kind of the official Elixir book, since it was revised by José Valim, Elixir's creator. And in the case of metaprogramming with Elixir, there's also this great book which will get you up to date with everything that you want to know about metaprogramming. And it's written by Chris McCord, which is the creator of the Phoenix Web Framework. And besides that, there's also other books like Elixir in Action, which is a great book which is more focused in the concurrency and distribution aspect of Elixir. And there's also Introducing Elixir, which is also a great overall book about the language. And there's also the Elixir Cookbook, which is written by a Portuguese guy called Paulo Pereira from a company called OnFidel. And if you want to check Elixir's webpage to get to know it, you can go to this address. It's the hub for everything about Elixir. Or you can go to the official Elixir forum, elixirforum.com. You can find me there. I'm part of the staff that runs the forum, and I'm pretty much there 24/7, so you can get me at that tag. I'm also on Slack at Elixirlang channel. And I also I am the organizer of the Lisbon Elixir meetups, and we had one just in September, which was done in Bright Pixel, and I'm preparing the next one soon. So probably in the next couple months there will be a new one. If you're interested, you can subscribe to the meetup. And that's it. If you have any questions, you can ask. Just don't ask me to solve your bugs, please. So that's it. Thank you. So, any questions? It doesn't need to be about metaprogramming with Elixir. It can be about Elixir in general. I can try to answer that.
Hello? Yeah.
Hi.
So, I've played around a bit with metaprogramming and macros.
Yeah.
And I've never really found the line which is the correct amount of macros. Do you think it's a matter of opinion, or it depends on the project, or there is like a sweet spot? Because I find particularly in Phoenix that there seems to be a lot.
In Phoenix? Yeah.
Yeah, in Phoenix. And I was just wondering if you had an opinion on, is the Elixir community being really exuberant with this new superpower, or should we use it even more because it's amazing?
Well, like I said, you must use macros responsibly. But yeah, maybe in your case you haven't still played a lot with macros, and it can be really difficult at first, and you seem like maybe you see some examples, and then it's hard to see how can this be useful. And a great deal of it really comes down to creativity, and since it's a new paradigm, right? It's like when you're in object-oriented and you go to functional, it's different, right? And in the case of metaprogramming, it's the same really, and it's true that maybe if you don't really explore Phoenix, it may look like it's doing a lot of magic in the background, but when you start exploring the source code and you understand it, it's actually really, really simple. And as I said, it's done with really few lines of source code. So, and it's really reliable framework. And to get good at metaprogramming, you really have to practice it. Like, for example, I wrote a library a few months back, which was inspired by another library, which used metaprogramming a lot. But in that library that the other guy wrote, it was really helpful to use metaprogramming. But since I was doing a similar library, I thought, yeah, this guy used metaprogramming, I also want to use it. And it was completely overkill. I ended up having a great deal of complexity where it wasn't needed. And so I learned that you must first understand about macros, and you must understand what you can do with it before you start getting deeper with it, right? So I don't know if I answered your question. I guess it's a matter of opinion, yeah? Yeah, but I think if you practice it more, you'll find it more appealing, and with some creativity, you'll find great productivity out of it.
So, yeah, the main reason I wonder it being a matter of opinion is because with Elixir being such a new...
Can you please speak up?
Sorry. If it's a matter of opinion, I find that an interesting viewpoint with Elixir being such a new language, because for the next few years, many of the people you will work with are, of course, going to be beginners to Elixir. Yeah. And so, you know, if we're all going to have the responsibility to train up more Elixir developers, a lower level of sort of metaprogramming seems helpful for building out teams and getting adoption.
You think that should be some more beginner level?
Well, yeah, if it's that much of a talent, is it a barrier to newcomers in some ways?
Yeah, I mean, it's actually quite a fun point, really, and I see a lot of people talking about Elixir, and one of the points that people always talk about Elixir is the metaprogramming aspect. Even if people don't know it, people can recognize the benefits of it. But I totally get what you're saying, that it's not some entry-level paradigm. But with time, and as Elixir gets more famous, it will probably something that will start to be talked about even at a beginner level. Because pretty much everything Elixir will have metaprogramming at some point. If it's not your library, it will be the source code. Or if you want to debug something, you probably will have to get to a metaprogramming level. So yeah, I think that for beginners, it's maybe difficult at first. But as Elixir gets more famous, it will definitely be something that you'll start seeing more and more.
Cheers.
So more questions? No? That's it? A question? No? No. Okay. So that's it, I guess. Thank you.